Car manufacturers don't build car factories in dense urban cities like.
If you think that EV engines are not as powerful as traditional gasoline-powered engines, you're not alone. This perception is almost ubiquitous, but the landscape of automobile manufacturing is changing rapidly, very rapidly. Electric cars are not only the future, but are becoming increasingly prevalent on our roads now. But the challenge of horsepower and range anxiety still haunts prospective buyers. Well, these problems, luckily, are about to be in the past. Why, you may ask? Well, Elon Musk is confident that this new engine will destroy the entire EV industry. So, how big of a deal is it? Well, let's find out. Challenges in the way of an EV revolution. Even as Tesla and other big-time automakers make significant strides in the EV revolution, several persistent challenges continue complicating the EV industry's path to universal adoption. These are systemic and consumer-focused hurdles that must be addressed to ensure EVs become the norm rather than the exception. One of the most enduring challenges is range anxiety, or the fear that an EV might run out of charge before reaching its destination. Naturally, drivers accustomed to the convenience of widespread gas stations are hesitant to switch to a vehicle that requires meticulous planning around charging stops. While Tesla's supercharger network and other fast-charging initiatives have attempted to alleviate these concerns, the infrastructure is still far from universal. Moreover, colder climates and hilly terrains can significantly reduce battery efficiency, exacerbating concerns. But the list does not end here. Luckily, the solution is also coming to the forefront. More on that later. Let's get some context first. Then there are problems in the supply chain. The production of lithium-ion batteries requires vast quantities of lithium, cobalt, and nickel, elements that are not only finite, but also concentrated in geopolitically sensitive regions. For example, cobalt mining heavily relies on the Democratic Republic of Congo, where concerns over child labor and environmental degradation have tarnished the industry's reputation. Meanwhile, the surging global demand for EVs has sparked a race for lithium resources, leading to inflated costs and fears of scarcity. This reliance on rare materials complicates the scaling of EV production, as manufacturers must contend with ethical, environmental, and economic pressures. Balancing electric motor power with energy efficiency is another technical dilemma that continues to challenge automakers. High-performance EVs, such as Tesla's Model S Plaid, demonstrate that EVs can rival or even surpass traditional combustion engine vehicles in terms of acceleration and speed. However, this comes at the cost of increased energy consumption and a reduction in driving range. Then there's the question of scalability and affordability. While Tesla's mass-market Model 3 and other budget-friendly EVs have made strides in affordability, the average EV remains significantly more expensive than its internal combustion counterparts. The answer to this seems simple: scaling up production. But this too comes with its own set of challenges, from managing supply chains to building gigafactories. The EV revolution remains a work in progress, but it is the path to the future, and a little patience in this arena will go a long way. Speaking of going a long way, let's see what Tesla has done. Tesla's 4680 battery cells will change everything. Under Elon Musk, Tesla is all set to redefine electric mobility. Their all-new 4680 battery cells represent the next chapter in this saga. These cells are 46 mm in diameter and 80 mm in height. They are larger than the previously utilized 18650 and 2700 cells, allowing for a higher energy capacity per cell, which can lead to improvements in vehicle range and performance. These cells use a dry electrode process, which eliminates the need for solvents in electrode production. This method not only simplifies manufacturing, but also reduces environmental impact and production costs. Additionally, Tesla has focused on reducing its reliance on cobalt, a material associated with ethical and supply chain concerns. By optimizing the cell chemistry, Tesla aims to minimize cobalt content without compromising performance, thereby addressing both cost and sustainability issues. The 4680 cells are in many ways an improvement over the older models. Their larger size and improved design contribute to a higher energy density, allowing vehicles to achieve longer ranges on a single charge. These cells are designed to deliver higher power, enhancing vehicle acceleration and overall performance. Also, the innovations in the cell design improve heat dissipation, reducing the risk of overheating and increasing safety. Moreover, the simplified manufacturing process and reduced reliance on costly materials like cobalt contribute to lower production costs, which can translate to more affordable EVs for consumers. Despite the advantages, the development and implementation of the 4680 cells is no easy feat. Transitioning from prototype to mass production requires overcoming technical hurdles to ensure consistency and quality at scale. Also, securing a stable supply of raw materials, even with reduced cobalt content, remains a critical concern, especially as global demand for EVs increases. Moreover, incorporating the new cells into existing vehicle architectures necessitates redesigns to optimize the benefits of the 4680 cells, such as structural battery packs that contribute to vehicle rigidity and safety. But the effort is worth it. These cells are poised to have a substantial impact on the EV industry. Their enhanced capabilities are likely to set new benchmarks for vehicle range, performance, and efficiency. On top of that, the anticipated reduction in production costs could make EVs more accessible to a broader consumer base, accelerating the adoption of electric transportation. Tesla's advancements may also prompt other automakers to innovate and invest in similar technologies to remain competitive in the evolving market. Plus, Elon Musk has now been appointed to lead the newly established Department of Government Efficiency under President Donald Trump's administration. This position places Musk at the forefront of efforts to streamline government operations and implement innovative solutions across various sectors. Naturally, Tesla's EV offerings are about to blow a hole through the roof. And it's not just about batteries. Tesla's revolutionary innovation. Tesla's origins in 2003 were far from the high-tech juggernaut it is today. Founded by engineers Martin Eberhard and Mark Tarpenning, the company began as a modest venture with a bold idea to prove that electric vehicles could be practical and desirable. Yet, it was the arrival of Elon Musk in 2004 that truly transformed Tesla's trajectory. With his $6.5 million investment and audacious vision, Musk quickly became the face and driving force of the company. Under his leadership, Tesla's ambitions soared. The release of the Tesla Roadster in 2008 marked a watershed moment, shattering the stereotype of EVs as slow and utilitarian. Instead, the Roadster proved that an electric car could be stylish, powerful, and exhilarating to drive, achieving an unprecedented range of over 200 miles on a single charge. Musk's vision for Tesla has always been about more than just cars. At its core, it's a mission to marry cutting-edge technology with sustainable energy. From the very beginning, Tesla has been defined by relentless innovation, guided by a philosophy of rigorous experimentation and problem-solving. Each challenge, whether it's optimizing battery performance, enhancing motor efficiency, or expanding manufacturing capacity, has been met with a refusal to compromise. Musk's approach is to tackle problems head-on, often achieving breakthroughs others deemed impossible. This ethos is what propelled Tesla to introduce groundbreaking technologies, like its proprietary battery architecture and the development of its autopilot system. Now, the stakes are higher than ever. The delicate balance between performance and efficiency has long been a central challenge in EV design. High-performance vehicles often sacrifice range and energy conservation, but Tesla's upcoming advancement promises to change this. While competitors like GM and Volkswagen race to refine their own electric platforms, Tesla's relentless focus on the future threatens to leave them perpetually playing catch-up. EV battery technology, current challenges, and future. While advancements in powertrain systems have enabled EVs to achieve breathtaking acceleration and top speeds, these gains often come at the expense of range. This conundrum places an unrelenting burden on battery technology, which must bridge the gap between high performance and the long distances modern drivers demand. Perhaps the most pressing issue, however, lies in charging speeds. However, the promise of ultra-fast charging remains an elusive goal. Although some modern EVs boast rapid charging capabilities, the technology is far from being the reality that customers expect. Many consumers, accustomed to the near-instant gratification of smartphone charging, are reluctant to embrace vehicles that still require considerable downtime to recharge, particularly on long road trips. However, battery innovation is not as easy as it sounds. Increasing the energy density of EV batteries, for instance, is one of the most challenging parts of EV manufacturing as a whole. Energy density, or the amount of energy a battery can store per unit of weight or volume, can only be boosted with significant trade-offs in safety, longevity, and cost, making it a resource-intensive and complex endeavor. Current lithium-ion batteries, which dominate the EV market, typically achieve energy densities of around 250 to 300 watt-hours per kilogram at the cell level. While this represents a significant improvement over older battery technologies, it falls short of the energy densities required to match the range and convenience of internal combustion engine vehicles. Increasing energy density involves refining the cathode, anode, and electrolyte materials. Most lithium-ion batteries rely on nickel-cobalt-manganese (NCM) or nickel-cobalt-aluminum (NCA) chemistries for their cathodes. Nickel increases energy density, while cobalt stabilizes the structure and prevents thermal runaway. However, cobalt is a critical bottleneck due to its high cost, which often exceeds $50,000 per ton. Nickel, while less contentious, poses its own challenges. High nickel cathodes are prone to thermal instability, which increases the risk of overheating and fires. Furthermore, nickel processing requires advanced manufacturing techniques, as impurities can degrade battery performance and longevity. To address these issues, researchers are exploring cobalt-free or cobalt-reduced chemistries, such as lithium iron phosphate or LFP, which sacrifice some energy density for greater safety, affordability, and cycle life. LFP batteries typically achieve 160 to 180 watt-hours per kilogram, but their longevity and lower cost make them attractive for mass-market and budget EVs. Fast charging introduces another layer of complexity. The ability to charge a battery to 80% in under 20 minutes, which can rival the refueling time of gasoline vehicles, places immense stress on the battery. During ultra-fast charging, lithium ions must rapidly diffuse into the anode, which is typically made of graphite. However, at high charging speeds, lithium plating can occur on the anode surface, leading to reduced capacity, increased resistance, and even short circuits. To mitigate this, researchers are exploring silicon-based anodes, which can theoretically store 10 times more lithium than graphite. While promising, silicon anodes face their own challenges, such as volumetric expansion of up to 300% during charging, which can crack the anode and degrade the battery. Then there's thermal management. High charging currents generate significant heat, and if not properly managed, this can lead to thermal runaway, where heat generation leads to further instability. Advanced cooling systems, such as liquid cooling, are increasingly being integrated into battery packs to dissipate heat and maintain safe operating temperatures. However, these systems add weight and complexity, which can offset gains in energy density. Longevity is also a pressing concern. While consumers demand batteries capable of lasting for over a decade or 1 million miles, as is also the ambition of Tesla's million-mile battery project, each additional charge cycle introduces wear and tear. Over time, this can reduce capacity and efficiency. To combat this, researchers are exploring solid-state batteries, which are far more durable and can achieve energy densities of 500 watt-hours per kilogram or more. Despite these obstacles, the industry continues to forge ahead, fueled by the promise of emerging technologies and alternative solutions. For companies like Tesla, solving the battery conundrum is more than just a technical challenge, it's a strategic imperative. As a pioneer in the EV space, Tesla has consistently pushed the envelope, from introducing the 4680 battery cell design to pioneering the use of new materials and manufacturing techniques. Then there's the software angle too. Software improvements and EV performance. As EV technology advances, so too does the complexity of the software that governs energy management, which is a critical component in optimizing range, efficiency, and overall vehicle performance. Modern EVs require intricate algorithms capable of balancing power distribution, monitoring battery health, and predicting energy consumption with remarkable precision. These systems are essential not only for improving range, but also for ensuring the long-term reliability of the vehicle. Then there's the integration of advanced driver assistance systems, or ADAS, and semi-autonomous features. These cutting-edge technologies rely heavily on real-time data processing, machine learning, and artificial intelligence to enhance safety and provide a seamless driving experience. From adaptive cruise control to lane-keeping assist and predictive navigation, such systems demand robust software. Perhaps the most critical factor in maximizing EV performance is the seamless integration of software and hardware, a domain in which Tesla has become a recognized leader. Unlike many traditional automakers that rely on third-party suppliers for their software needs, Tesla designs and develops its software in-house. This level of control enables Tesla to implement over-the-air updates that not only fix bugs but also enhance performance, introduce new features, and improve energy management without requiring customers to visit service centers. Such updates keep Tesla vehicles at the cutting edge of innovation, fostering a sense of longevity and adaptability that is unmatched in the industry. Moreover, Tesla's software ecosystem extends beyond energy management and driver assistance to include user experience and connectivity. The central touchscreen interface in Tesla vehicles exemplifies the company's commitment to intuitive, user-friendly design. From controlling climate settings to accessing navigation and entertainment options, the software is tailored to provide a cohesive and engaging experience for drivers and passengers alike. This attention to detail is further amplified by how Tesla leverages billions of miles of real-world driving data to continuously improve its systems. However, the increasing reliance on sophisticated software introduces its own set of challenges. Ensuring cybersecurity, maintaining system reliability under extreme conditions, and managing the vast amount of data generated by connected vehicles are just a few of the hurdles that automakers must address. Naturally, automakers will need to prioritize seamless hardware-software interplay, robust cybersecurity measures, and the ability to adapt quickly to emerging technologies. Tesla's success in this arena serves as a benchmark for the industry. Speaking of setting benchmarks, Tesla has done quite well in other areas too. Tesla's innovation and approach. Tesla's biggest strength is perhaps its vertical integration of the supply chain, which grants the company unparalleled control over critical components such as batteries, motors, and software. By taking ownership of these core elements, Tesla ensures quality, reduces dependency on external suppliers, and optimizes its manufacturing processes. Then there's an impressive network of gigafactories, strategically located across continents to achieve scalability and reduce production costs. These state-of-the-art facilities are designed to maximize efficiency and minimize waste. By producing batteries and vehicles under one roof, Tesla reduces logistical complexities and streamlines production. These gigafactories incorporate renewable energy sources like solar and wind to power their operations. This integrated approach not only cuts costs, but also reinforces Tesla's vision of a sustainable future. Then there's a difference in the approach to problem solving. Unlike legacy automakers, which often rely on incremental improvements to existing technologies, Tesla embraces bold, transformative ideas that redefine industry standards. From the inception of its first vehicle, the Tesla Roadster, to the groundbreaking advancements in autonomous driving and energy storage, Tesla has consistently demonstrated a commitment to pushing boundaries. In stark contrast, many legacy automakers struggle to match Tesla's pace of innovation due to their entrenched processes and deep-rooted combustion engine cultures. These companies, burdened by decades of reliance on internal combustion engine technology, often view the EV transition as a threat rather than an opportunity. Their approach to EV development tends to favor cautious, incremental progress, driven more by regulatory compliance than by a genuine commitment to innovation. Moreover, Tesla's direct-to-consumer sales model eliminates the need for traditional dealership networks, allowing the company to maintain control over the customer experience. This model not only reduces costs, but also ensures that Tesla's vision and values are consistently communicated to its customers. By bypassing intermediaries, Tesla can swiftly implement changes, gather customer feedback, and provide seamless support, further solidifying its reputation as an industry disruptor. But is this really a one-sided battle? Well, maybe for now. But not for long. What to expect from legacy automakers? Legacy automakers, long dominant in the automotive industry, now find themselves facing a monumental shift toward electric mobility. However, their response to this transformation has been hampered by a combination of cultural and financial inertia. For decades, these manufacturers have operated within a framework deeply rooted in internal combustion engine technology, with established supply chains, production processes, and corporate structures designed to support fossil fuel-powered vehicles. The transition to electric vehicles requires not just new technologies, but also a wholesale re-evaluation of business models and priorities, an undertaking many legacy automakers have been slow to embrace. While companies like Volkswagen, General Motors, and Ford have committed significant resources to EV development, their efforts have often been met with technical, financial, and strategic hurdles. Other legacy brands, including Porsche and Toyota, have taken different approaches, some focusing on high-performance EVs, others hesitating due to long-standing investments in hybrid technology. Volkswagen has arguably been one of the most aggressive legacy automakers in shifting toward electric vehicles. Following the Dieselgate scandal in 2015, the company pledged to reinvent itself as an EV leader, committing over $180 billion toward electrification and battery technology by 2028. The Volkswagen ID.4, an electric SUV, has seen commercial success, particularly in Europe, and the ID. Buzz, a modern electric take on the classic VW microbus, has generated significant consumer interest. However, Volkswagen has struggled with software integration issues in its EVs, leading to delays and complaints. The company's flagship EV platform, MEB or Modular Electric Drive Matrix, has been used across its brands, including Audi and Skoda, but the software side of its vehicles has been plagued with reliability concerns. Despite these setbacks, Volkswagen remains one of Tesla's strongest competitors in Europe. General Motors has also made bold promises regarding EVs, declaring plans to phase out gasoline-powered cars by 2035. The Chevrolet Bolt EV, initially praised for its affordability and efficiency, suffered a massive recall due to battery fires. However, the company has rebounded with its Ultium battery platform, a flexible architecture designed to support multiple EV models. Vehicles like the GMC Hummer EV and Cadillac Lyriq showcase GM's ability to produce high-performance electric vehicles, but the rollout has been slow. GM's partnership with Honda to develop affordable EVs was recently scrapped, highlighting the difficulties in scaling production while maintaining profitability. Ford has taken a pragmatic approach, leveraging the strength of its best-selling models to introduce EV versions. The Ford Mustang Mach-E has been a commercial success, blending performance and practicality, while the Ford F-150 Lightning has capitalized on America's love for trucks. The F-150 Lightning, in particular, has been praised for its innovative features, such as vehicle-to-grid or V2G capabilities, allowing it to serve as a backup power source. However, Ford has faced supply chain disruptions and production bottlenecks, leading to delays and price hikes. The company also reported financial losses in its EV division. Porsche, a subsidiary of Volkswagen, has positioned itself as a leader in high-performance electric vehicles. The Porsche Taycan, launched in 2019, was one of the first true Tesla competitors, offering sports car-like handling with an electric powertrain. However, the Taycan's range has been a point of criticism, as it lags behind Tesla's long-range models. Toyota, in contrast, has been more reluctant to fully embrace EVs, largely due to its early success with hybrid technology. The company pioneered hybrid vehicles with the Prius, but its commitment to hydrogen fuel cell technology has delayed its entry into the EV market. The Toyota bZ4X, its first mass-market EV, faced a rocky launch, including a recall due to wheels potentially detaching from the vehicle. While Toyota now claims to be accelerating its EV strategy, its hesitation has put it behind competitors in the all-electric space. Other legacy automakers, including BMW and Mercedes-Benz, have made steady progress, with BMW's i4 and iX and Mercedes EQ lineup offering premium electric options. However, these brands face the challenge of balancing luxury features with range and efficiency, as well as competing with Tesla's dominance in software and battery technology. While Tesla's willingness to take bold risks, its vertical integration of the supply chain and its focus on purpose-built EVs have given it a decisive advantage. Legacy automakers are here to stay and can invest a serious amount of resources to compete with Tesla. Even if the situation does not favor them as much now, it can in the future if they make similarly bold strides. Speaking of innovation, where do we stand on EV engines or motors? The engineering challenges of EV motors and Tesla's response. Unlike internal combustion engines, which rely on controlled explosions, electric motors must adapt to entirely different principles of energy conversion. However, high-performance EV motors generate substantial heat during operation, particularly under heavy loads or during prolonged periods of acceleration. Effective thermal management is essential to prevent overheating, which can lead to efficiency losses, degradation of motor components, or even catastrophic failure. Another key issue lies in the reliance on rare earth materials such as neodymium, which are integral to the production of high-performance permanent magnets used in many EV motors. While these materials enable compact and efficient motor designs, they introduce vulnerabilities in terms of cost and supply chain stability. Balancing efficiency and power is another hurdle for EV motor design. High-power motors often come at the expense of efficiency, reducing the vehicle's overall range and placing additional strain on the battery. Conversely, motors optimized for efficiency may lack the power needed for high-performance applications, such as towing or rapid acceleration. This trade-off impacts not only consumer satisfaction, but also the vehicle's marketability, as buyers increasingly demand EVs that combine extended range with dynamic driving capabilities. The industry's challenges are exemplified by failures such as the Electromechanica Solo EV, a single-seat electric vehicle that struggled to meet consumer expectations. Despite its promise of affordability and eco-friendly mobility, the Solo EV faced criticism for its technical shortcomings. So, how does Tesla meet these challenges? Well, their answer is the carbon-wrapped rotor technology, first implemented in the Model S Plaid. For context, in traditional electric motors, rotors are typically constructed from metal components. Tesla's approach involves encasing the rotor in a carbon fiber sleeve, which allows for a tighter binding of the rotor assembly, enabling the motor to generate a stronger electromagnetic field. This results in improved torque and overall motor performance. It also permits the rotor to achieve higher revolutions per minute without compromising structural integrity. This capability allows the motor to maintain high power output even at elevated speeds. Carbon fiber also has excellent thermal properties, aiding in better heat dissipation and maintaining optimal operating temperatures. This is yet another benchmark for electric motor performance. By achieving higher efficiency and power output, this innovation challenges other automakers to explore advanced motor designs to remain competitive. The success of this technology in the Model S Plaid may lead to its adoption in future Tesla models and potentially influence industry-wide standards for electric motor construction. Since the demand for more efficient, powerful, and sustainable motor designs is growing fast, This recent success will ensure that EV motors evolve in tandem with the broader advancements in electric vehicle technology. However, while innovation at Tesla is at an all-time high, there is one big problem that the company is facing: the China factor. China's rapid advancements in EV battery technology and infrastructure have positioned the nation as a formidable competitor in the global market, creating significant challenges for Tesla and Western automakers alike. Chinese companies like CATL and BYD are leading the charge with their innovative battery models, including lithium iron phosphate or LFP batteries, which are not only cost-effective but also boast impressive safety and durability. These LFP batteries, while offering slightly lower energy density compared to traditional nickel-cobalt-manganese or NCM cells, are more affordable to produce and have a longer lifespan, making them particularly appealing to budget-conscious consumers and fleet operators. Adding to the competition is China's growing network of battery swapping stations, which allow drivers to replace depleted batteries with fully charged ones in minutes. Companies like NIO have pioneered this model, offering a faster and more convenient alternative to traditional charging methods. This infrastructure not only eliminates range anxiety for EV owners, but also provides a scalable solution for densely populated urban areas where charging stations might be limited. With over 1,400 battery swapping stations in China and plans for global expansion, this innovation has further heightened competition in regions like Europe and the United States, where Tesla and other automakers currently dominate. China's competitive edge also lies in its ability to produce EVs and batteries at significantly lower costs, thanks to streamlined supply chains and government subsidies. This has allowed Chinese automakers to offer high-quality EVs at prices that undercut their Western counterparts, making them increasingly attractive to price-sensitive consumers. In markets like Europe, where competition is fierce, Chinese EV brands have already begun to gain a foothold, with affordable models offering impressive features and specifications. The impact of this competition is being felt in the United States and Europe, where Tesla and legacy automakers now face mounting pressure to innovate and reduce costs. This, however, is easier said than done. To remain competitive, Western automakers must step up their game by investing heavily in research and development, building robust EV infrastructure, and embracing bold design and manufacturing strategies. The company, despite its many successes, needs a significant shift in strategy to cut the gap between Western and Chinese EV industries. Otherwise, the global automotive landscape could change forever. However, the future is anything but bleak for Tesla. As both a leader and a provocateur, Tesla has continually pushed the boundaries of what is possible, often forcing competitors to play catch-up rather than innovating independently. Elon Musk's ambitious vision has positioned Tesla as a disruptor, with its cutting-edge advancements in battery technology, motor design, software integration, and production scalability setting benchmarks that redefine industry standards. Tesla's relentless pursuit of optimization, from developing batteries capable of ultra-fast charging to refining autonomous driving algorithms, ensures that the gap between it and its competitors only widens. For many of Tesla's Western competitors, the pressing question is no longer how to beat Tesla, but whether the race is even still winnable. Legacy automakers, burdened by entrenched processes and a culture rooted in combustion engine technology, find themselves outpaced by Tesla's agility and forward-thinking approach. Moreover, startups in the EV space often struggle to achieve the same level of integration and innovation. While Tesla excels in these key areas, affordability is one area where Chinese automakers can deliver a serious hit. Tesla must now contend with this added burden by not just leading the industry, but redefining its parameters to such an extent that it leaves little room for true competition. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, Don't miss this video you see on your screen right now. It's truly unbelievable.